Hello people, welcome to NFI online course Learn 5 PLC in a Day. My name is Rajveer. I'm one of the educator in NFI, and in this video we are going to learn about basic industrial control. So this is the start of our course Learn 5 PLC in a Day. We will start from the scratch. If you know all these things already, you can skip this lesson. Alright, so in this lesson we will see input switches, output components, and understanding basic circuits. So you can see some switches here. We are going to understand what are the symbols for that and how to make circuits using these switches. Alright, so let's proceed. So let's talk about industrial control panel. Now in every industry you will see there is a machine sometimes, yeah. Most of the time we have machines, sometimes it's a software industry, but I'm talking about a factory automation industry where you are producing something, alright. In that machine you will see a control panel, something like that. In this panel you will see various switches, various indicators, and some dials, some emergency switches. So we will understand how to connect these switches inside the panel, how to make a wiring of these switches, how to wire these circuits. Alright, this is another example of how a control panel looks like. So whenever you see this panel, you can understand that these are some input switches and output switches, which we are going to see now. Okay, so let's look at the physical look, some symbols of these switches. So the very common switch is push button, normally open. It is also called push button or push switch. Someone says button, someone says switch, so it's okay. So this is how it physically look like, and its JIC symbol is that and IEC symbol is that. These are the two standardization for the symbols. Alright, it's up to you which one you want to use, but if you see something like this in the drawing, it means they are using this push button. Alright, then you have toggle button, which is normally open. This is a toggle button. Now the difference between a push button and the toggle button is that when you press the push button, there is a spring inside it. When you release the button, it will come out. So let me take a pointer here. Yeah, if you press the button, there is a spring inside it. Spring got pressed. When you release the button, because of the spring force, the button comes out automatically. Okay, that's why it's called push button. But in the maintain button, there is no spring. When you press the button from here to here, it maintains the state. That's the difference. So in case if you need some push action, you can use a push button. For maintained action, you can use a maintain button or a toggle button. Alright, so then you have a selector switch. In case if you want an output, if the switch is closed, you can use a selector switch. By close I mean it has two states. This is the state 1. At state 1, the signal which is coming at this point will be output at this point. When this goes at states 2, the signal at this point will go out at this point. This is a 2 state. Here we only have 1 state. If you press the button, the signal here will go out. If you turn off the button, the signal will be blocked here. Similar in the case of push button. When you press the button, this will be like this. It will pass the signal. When you release the button, the signal will be blocked here. Okay, but not in case of selector switch. You have 2 outputs, in case of on, in case of off. Alright, and that's the symbol for IEC symbols. Then you have push button, normally closed. Now look at this symbol compared to this symbol. Alright, let me just remove the... Yeah, you will see the difference here. Here this is normally closed. When you're not pressing the switch, it is already passing the signal. Okay, when you press the switch, this will come down and it will be like this. It will block the signal. So this is basically the opposite of normally open. Alright, when you press the button here, then it will pass the signal. But here when you press the button, it will block the signal. So it's the opposite of normally open. Very easy to understand. Okay, and then you have emergency switch, which is normally closed. And this is a general representation. It is also called mushroom head, so you have a different representation at the top, but it's almost similar to NC switch. It's same. The function is same. It just look different because it has some emergency controls. It will stop the whole operation most of the time. It is used in case of emergency. When there is some accident is happening, you can press this button and everything will be stopped. This is how you have to program it, or you have to wire the circuit in such a way. So these are the different switches, input switches we can have in the panel. Now let's see some basic output switches. Output components. We have the indicators. Now these are the typical light indicators, and that's the symbol for that. Now these indicators can be 24 volt actuated, could be DC, could be AC, and it could be 110 or 220 AC volt actuated. Okay, so it's up to you whether you want AC or DC. Now that depends the power supply you have in your panel. If your panel has AC supply only, then you have to use only AC indicators. If your power supply also have DC, you can use DC and AC. It's up to you, up to your application. All right. Then you have motor. It's a very common device. It's a single phase motor, and that's the symbol for that. It can be driven at 110 VAC or 220 VAC in some countries. Then you have three-phase motor, and that's the symbol for three-phase, and it can also be at 220 and 440, could be in star or could be in delta. So generally in star we run at 440, in delta we run at 220 volts. And if you have 110 volt AC supply in your country, you can use 110 volt as single phase. Yeah, it's up to you the supply you have. So that's the typical industrial panels, and you have all these components here. So what I'm going to do now is I'm going to show you a software where I have a panel and I have installed all these switches. So we'll just understand how these switches react, how the switches works, how you have to press it. Okay, so I will go out from this presentation. So let's go to my software. This is Factory IO. Now this is the panel you can see here. Now in this panel you have this emergency stop. So when I press emergency, it goes inside of this panel. You can see from here. And when I release it, it comes out. Okay, this is press and this is release. Sometimes it does not release by pressing it. To release it, you have to rotate it. Okay, this is a software thing, so I cannot rotate it here, but it comes out when you rotate the button. You can see it twists automatically. So that's the emergency. Now look at here. This is the signal. Okay, so emergency is released right now, and this is passing the signal because it's an NC switch. So when I press the switch, it will block the signal. That's the opposite of NO. Let's look at NO. This is NO. When I press NO, you can see this indicator goes on. When I release, it goes off. But here it's the opposite. When I release it, it passes the signal. Okay, that's the opposite. But if you see here, this is an NC switch. This works similar to emergency. You can see that here. Okay, this one and emergency works similar. Now you have selector state. This is the state 1 and that's the state 0. If you see here, state 1 is already getting a signal, and this is the state 0. So selector switch selects which state you want and from which state you want the signal. Okay. Then you have these indicators. Now these are the indicators here. I will forcefully turn it on. That's how it looks when it goes on. And that's for red. So green is generally for on operation and red is generally for off operation. We indicate something which is off by red indicators. All right. So these are the two indicators and some NO switch, NC switch, emergency and selector switch. And that's some layout of panel. All right, so now let's go back to presentation, and we have some questions here. We have some question which says design a series circuit using push button, design a series circuit using toggle switch. So we have to now design the circuit. So if you understand the basic electronics about AND gate and OR gate, you will understand what I'm trying to ask here. All right. So, okay, there is a mistake here. Design a parallel circuit is OR. Here it's also OR. That's a silly mistake. Anyway, so let's go to another software. I'm going to design the circuits here. So again, here I have to change it, I guess. Yeah. This mistake is when I copy pasted the sentence. I forgot to change to OR. Alright, so the first circuit says design a circuit using push button and should be an AND circuit. Now AND circuit says if two inputs are on, then output is on. Okay. So what I'm going to use is I'm going to use two push buttons, because AND gates I need more than one input. So I'll take one push button from here, let's call it X1, and another push button, let's call it X2. Okay, so I have to connect it together because it's in series. So in series you connect the components end to end like this. Okay. Now we need to actuate something. For that we need an output. So I'll go to the output component and I will take an indicator. That is the symbol of indicator. I will name it as KQ. So connect this together here. And now we have to give some power supply, because if I turn it on, there is no signal here. So I have to use a power source. I can use line neutral or 24. So let's use 24 volts. It's a DC source. So 24 volts goes to one end, and the other end will be connected to 0 volt, because the other end needs a low potential. When I press this switch, the high potential will travel from here to here to here to here. Now this needs a low potential to maintain the potential difference of 24 volts. That's why it will be on. So this is the circuit. Let's try that. Now you can see 24 is coming here. I press it, keep pressing it. It comes here. When I press here, the indicator goes on. Okay. When I release, it will be off because the signal is blocked here. This is NO switch. I hope it's very easy to understand. Okay. So let's see the next circuit. Devise a parallel circuit using push button. Alright, we'll come to parallel a bit later. Let's see, devise a series circuit using toggle switch. Now we need a series again, but switch is different. So I will just copy paste this one, remove these two switches. I will take a toggle switch from my library. This is my toggle switch 1. Let's call it X3. Another toggle switch. Let's call it X4. Okay. Now simulate the circuit. Now the only difference is I don't have to keep pressing the button. It will maintain the state, unlike push button. Okay. But if I just, in the software, if I just drag the switch, it will hold it just to check the system. Okay. Test the system. But practically the push button is going to release its state when you release it. Okay. Not in case of toggle button. We don't have toggle button in this software. But anyways, this is a toggle button, and that's another series circuit. Okay. Now next circuit, let's design a parallel circuit. Now it asks me to design a parallel using push buttons. So I'm going to again copy this one. But now we need a parallel. So in parallel, what happens? You connect switches like this. This makes a parallel circuit. The benefit of parallel circuit is you have to make it OR gate. Alright, I need to change this OR here, and this will be again my mistake, and here. Okay, so yeah, so let me just drag it above. Now you will see here, if I press any of this button, my output will be on. This is called a parallel circuit. Now how you can use it? Suppose you have an environment. Let me just let me take environment. Let's say we have this machine here. Okay, a robotic machine. Now I want this machine to be started from this button, and I also want this machine to be started from another button which I want to take here at this place. So I need two start operation, okay, from two buttons. In that case, I will take two NO switches to actuate the output. Here I'm using indicator as an example, but you can understand why we need a parallel circuit in case if you need two inputs to actuate something independently. So when I press this, the output will be on. Also, if I press this, the output will be on. That's called a parallel circuit. It's very easy. I hope if you have studied engineering science, then you can relate it to your subject. Okay, similarly design a parallel circuit or using toggle switch. Okay, so I will copy this toggle switch logic from here, and in a similar way I will connect it like this. The only difference between push button and toggle is toggle holds the state. So here this is getting on, and here also it's getting on. If you turn on both, nothing will happen, the output will be on. Same in this case. Okay, so this is your OR gate. Okay, now it says design a NOT gate circuit using NC push button. Now NOT gate means when input is high, output is low. When input is low, output is high. What does it mean? I will take an NC switch, let's call it X4, and I need 24 volt supply. I will put it here. I need an indicator that comes here. I will just connect it directly to Q. and output will be here. Okay, now let's test this logic. Here you can see that it is already passing the supply. That's why it is on. So it means when input is low, by input low means I haven't pressed the switch, then the output is high. If I press the switch, which means I'm giving some input, the output is low. This is called a NOT gate circuit. I hope it's not that difficult, right? Okay, now next circuit is a little bit interesting. It says design a circuit realizing NAND gate using toggle button. Now if you don't know what is a NAND gate is first you connect the AND gate and then you inverse its logic, which becomes a NAND gate. Okay, it's AND plus NOT. So this is the AND and this is the NOT. So AND plus NOT is a NAND gate. Okay, but how to make it in industrial control circuit? I will give you a hint of the NAND gate by its truth table, which is written here. Now you can see that if both the inputs are low, output is high. Okay, I'm not pressing any of the switch, output is high. If I press one of the switch, output is still high. Okay, if I press switch A, output is still high. But if I press both the switches, then output is low. This is called a NAND gate. Okay, so let's design that. So in this case, if you want to try by yourself, you can pause the video, you can try yourself. Otherwise, we will continue. So I'm going to use, I can use push buttons in this case, right? So I will use this circuit. I just want to copy it. I will make some changes here. Although it says toggle switch, all right, we'll take a toggle switch. Now here we need an NC. Okay, let's call it X5 and another NC, X6. Generally we don't have NC toggle switches because if it's a toggle switch, you can move it to another position and you can call it NC, which doesn't make sense. But this is for explanation. We do have these concepts in PLC, which you will understand later in the PLC lessons. Okay, now look at here. When both the inputs are low, then output is high. Come here. When both the inputs are low, both are 0, 0, output is 1. Okay, so output is working. Maybe I can. Okay, it's okay. So when none of the input is pressed, output is high. When I press one of the input, output is still high because it's going from here. Okay, if I press the other input, output is still high because the signal is going from here. This is what it says. If any of the input is high, output is still high, output is still high. But if both the inputs are high, output is low. So in this case, if I actuate both the inputs, then output gets low. This is called a NAND gate. All right, you can realize this using any example. Like if both the sensors are true, then output is true. If any of the sensor goes off, output is still true. If both the sensor goes off, then your output is off. Okay, you can maybe troubleshoot somewhere in the sensors using this logic. Okay, so this was NAND gate realization. Now the next one you should try by yourself in case if you get the idea of how to make the NAND gate. We have a NOR gate. Now if you understand what is a NOR gate, here's a truth table. It says if both the inputs are low, output is high. That's the only case where the output will be high. In all the other combination, like if any of the input is high, output is low. If both the inputs are high, output is low. This is called a NOR gate. In this case, what you can do is, I will just copy this one again. If you want to design yourself, you can pause the video, otherwise we'll continue. So in this case, what will happen? This will come in series. That's it. This makes your NOR gate. Let's test the logic with the truth table. All right, when both inputs are 0, output is high. When both inputs are 0, output is high. Now in all other combination, output is low. Let's see. If I press this one, of course the supply will be blocked here, this will be off. Or if I press this one, supply will be blocked here and this is off. If I press both, of course this will be off. So this is a NOR gate. The NOR gate says 0, 0, output is 1. Okay, this is a NOR gate. Now comes the most interesting gate, which says a XOR gate. And let's have its truth table. It says if both inputs are low, output is low. If any of the input is high, either B or either A, then output is high. Otherwise, if you turn on both inputs, output is low. So it's a bit complicated, right? So how to make it? Now if you, I don't know if you know, it's a Boolean formula for XOR gate is A bar B. Now I don't know how to put a bar here, so I'm going to use this symbol, A bar B plus A B bar. Okay, it means inverse of A plus B. This is OR with A and inverse of B. This is the realization in Boolean. Okay, so similarly we have realization in NAND and NOR. Okay, so to understand this, how we can make it in industrial control, let's come here. Now you can see here that we need A, and it's A inverse and A together. We need two switches, two outputs from one switch. It should also give NO, it should also give NC. How is that possible? In this case, we are going to use the selector switch. Okay, the selector switch which we have seen here. Because selector switch has two states. This one, it has two states. In one state, it gives the output, this one. In another state, it gives the output here. Alright, so let's see how we can use it. So I will need some selector switch that comes here. This is my switch 1 and that's my switch 2. Okay, and now I need an output. I will copy this here. Power supply, of course, 24 volts here. Now try to understand how we will make this switch. I need, first I will give input to my switch here. Okay, now if you understand that this is the NC part, the top one, let's split the switch into NO and NC. This is the NC. Now NC of switch A will go in the series of NO of switch B. If I'm calling it A, let me just write it here. This is B. Okay, NC of 1 will go to NO of 2, and this was going to my indicator. This is how you have to make the first logic. Secondly, NO of second will go to NC of B. NO of A go to NC of B, and this also goes to my switch. Now see what's happening if I go to online. Now both switches are off. I'm not pressing. Both states are 0. Okay. If I turn on this switch, now let's see what's happening. This 24 is here, it's passing from here, but it is blocked here. Okay, this 24 is here, it's blocked here, but this is passing the circuit. So when I press the switch, now what's happening? 24 is coming from here, from this NC, and switch is on. It means this is 1, this is 0, switch is on. Now if I turn on this switch B as well, this is off. Why? Because the signal from here, it's blocked here. So this is 1, output is 0. This is what it says. And both the inputs are on, output is 0. If any of the input is on, then output is on. Let's do that again. I'll go back to 0, 0. Now this time I will actuate this one. So when I actuate this one, this was NC, going to this NO, and it is connecting my Q. So when this is high, this is 0, output is high. When this is high, output is low. When this is high, this is 0, output is high again. If both are low, output is low. Alright, I hope you understand this simple logic gates, and using these NO and NC combinations, you can make many different circuits in your control panel. And although I haven't used the motors here, because I want you to understand motors when we talk about relays, because that's the most appropriate way to make motor circuits. So this was all about the NO and NC and toggle and push buttons. You can take a copy of this presentation. I will paste the circuits here and you can keep it as a copy. All right. Thank you for watching, and if you have any doubt, you can put a comment below this video, and I wish you have a nice day.